Hi students, good morning to all of you. Today we are going to discuss about dipole moment part 2. In part 1 we did what is dipole moment, definition and units and what is the cause for dipole moment. Now today we are going to discuss about how to find the dipole moment of different molecules like diatomic molecules, triatomic molecules, tetratomic molecules. This part is important for objective examination of you. Let's start here. The dipole moment is nothing but a charge into distance between the two poles of a bonded atoms, right? So if the dipole moment is 0, that is non-polar molecule. If it is not equal to 0, some value is there, that is polar molecule. That means the polarity of a covalent bond is expressed in terms of dipole moment. If two poles are there, right? The two poles, there is a dipole. The magnitude of dipole or the degree of dipole of a covalent molecule is to be understood by knowing the concept of or by applying the concept of dipole moment. Correct? That is the degree of dipole. The degree of dipole is expressed in terms of dipole moment, or you can say the magnitude of dipoles or the magnitude of polarity of a covalent molecule. The magnitude of polarity of a molecule, of a covalent molecule, is expressed in terms of dipole moment, right? Now, if the dipole moment of a molecule is greater, then polarity of molecule is also greater. Generally, dipole moment of a covalent molecules depends on spatial arrangement of atoms. So dipole moment depends on spatial arrangement of atoms, right? For example, in case of diatomic molecules, that is AB type, two atoms are there in the molecule. The molecule is having two atoms. Di means two atoms are there in the molecule. In case of diatomic molecules, if the two atoms are similar, for example, that is if the dipole molecules having similar atoms, then for that the dipole moment value is 0. For example, H2 molecule, F2 molecule, Cl2 molecule, okay, O2 molecule, N2 molecule, right? So these are all similar atoms are there. That's why both atoms electronegativity is same. If electronegativity is similar, there is no difference in the electronegativity. There is delta E. Electronegativity difference is 0. Then dipole moment also 0. If electronegativity difference is 0, then the dipole moment also 0. Got it? Right? That molecule we have to call it as non-polar molecules. These are all non-polar molecules. Non-polar molecules, right? Because two poles are not developed, positive and negative poles is not developed because both atoms are similar types. Electronegativity difference is not there, right? So that's so that are no development of two poles, no dipole development. no dipole development, no polarity. So that is non-polar molecules, right? So here no dipoles developed because having same electronegativity. Got it? Next one. If the diatomic molecules having dissimilar atoms, in this type of molecules, the dipole moment is not equal to 0. Some value is there. For example, if you take here HF, HCl, HBr, HI, right? Here the electronegativity of hydrogen 2.1, fluorine is 4.0. So electronegativity difference is there. If electronegativity difference delta N is not equal to 0, then for such molecules dipole moment is there. So here in this case, fluorine is more electronegative. That's why the electron pair moves more towards the fluorine. It develops partial negative charge over the hydrogen, develops partial positive charge. Two poles are developed. So dipoles are developed here. So dipoles are developed here. If dipoles are developed means, then the magnitude is there, right? Charge is there, distance is there. So that's why these molecules, two poles are there, dipoles are developed. It is a polar molecule. In these molecules, the dipole will have some value. These molecules you have to call it as polar molecules. And HF, HCl, HBr, HI. As all have same dipole moment? No. It is different. How can you decide? That is, the dipole moment is directly proportional to electronegativity of the element. Here fluorine is more electronegative. That's why the dipole moment of HF is greater. Next HCl, next HBr, next HI. Right? Got it? Is it clear? Okay? Right. If electron into the element is more, dipole moment is also more. That's why HF has more dipole moment, HI is less dipole moment. Then if you take it here, a carbon monoxide molecule also. So in carbon monoxide molecule, CO molecule, another example. If you take a second example, carbon monoxide. So with the carbon dioxide, 3 bonds are there. So that's why electronegativity difference is there. Okay. So here, over the oxygen atom, there is partial negative charge. Carbon gets partial positive charge. So that's why here also it is also dipole moment value is there. Okay. So it is also polar molecule because the two atoms are different, dissimilar atoms, not similar atoms, dissimilar atoms, right? Okay, that is. Next one. So in case of diatomic molecules we did. Next one, in case of triatomic molecules. The molecule which is made up of 3 atoms, tri-atoms, 3 atoms are there. So in case of triatomic molecules like Ab2 type, 1 central atom and 2 bonded atoms, surrounded atoms. So in these molecules, the dipole moment is how to calculate, how to find out. So in these molecules, the dipole moment depends on bond dipoles. So for example, it is a dipole moment of one atom, that is mu1, another atom, that is mu2, right? And the dipole moment is a vector quantity. It has direction and also magnitude. The resultant dipole moment of these two these two poles is in this direction. The resultant dipole moment. So that's why here the dipole moment of these molecules, the resultant dipole moment is calculated by using a formula, that is root of mu1 square plus mu2 square plus 2 mu1 mu2 cos theta. Right. We can get it by using this. The relationship is the dipole moment is directly proportional to cos theta. Right. That means it is inversely proportional to theta. That is a bond angle. In a covalent molecule, it have bond angle is more, dipole moment is less. Okay. So by using this relationship, we can find out the dipole momentum of so many molecules. Based on bond angle only you can get it, right? For example, I will do it. Bond angle is more, dipole moment is less. A molecule, two molecules, in one molecule the bond angle or the theta value, the angle between the two poles is 60 degrees. In the another molecule, the theta value of the two poles is 120 degrees. Bond angle is more, 120 degrees. So theta is more, 120 degrees. Then what about the dipole moment is less? Got it? Such type of questions also appear taken. Okay. Now here, so in case of triatomic, some molecules would you know. This is the formula I gave here. Okay. So molecules, for example, here, take it here. The molecule is a carbon dioxide molecule. Central atom carbon and oxygen. So triatomic molecules AB2. So central atom is carbon and two oxygen atoms are there surrounded. Right. Compared to carbon, oxygen is more electronegative. So the electron moves more towards the oxygen. The moving of electrons. So momentum of that is dipole moment is towards the oxygen. So both have same magnitude but on opposite direction. So both are cancelled each other. The resultant dipole moment is 0. So that's why it is a non-polar molecule. Non-polar molecule. Right. Let me take another example. HgX2. Central atom is Hg and 2 X is a halogen, it may be chlorine. Okay, if you take chlorine, Cl. So Hg is a metal, chlorine is non-metal, it have more electronegativity, so that's why the moment of the electrons towards chlorine, so both have same magnitude, it is a V1, it is a V2, both have same magnitude but operating the opposite direction, so that's why the dipole moment both are cancelled each other, you will get 0, net dipole moment is 0, and it is also non-polar molecule, right. Then take it here, carbon disulfide, CS2. So here central atom is carbon and it is surrounded by 2 sulfurs, right, 2 sulfur atoms. You have to represent this one, there is a carbon 4 bonds, 1, 2, 3, 4 bonds, right. So here sulfur is more electronegative, the bond dipoles is towards the sulfur. So the magnitude of M1 and M2 is a same value but opposite direction. So that's why both are cancelled each other. So the dipole moment is 0. It is also non-polar molecule. Right. Then if you consider here another molecule, that is beryllium chloride molecule, BeCl2. Here central atom is beryllium and the 2 chlorines are surrounded. So beryllium is a metal and chloride is non-metal, so it have more electronegativity. So that's why the bond dipoles moves towards the chlorine. So the magnitude of both the dipole moments is equal, but both are cancelled each other because of opposite direction. That's why the net dipole moment is 0. It is also non-polar molecule. Got it, my dear students? Up to here, okay? Is it here? Comment fast. Comment fast. Yeah. Read fast. Yeah, can I erase it now? Fine. So the dipole moment, by using this we can find out the polarity of a molecule. The molecule have zero dipole moment, it is non-polar. So in case of CO2, CO2 is non-polar because dipole moment is zero, but CO, carbon monoxide, is dipole moment is not equal to zero. So that's when we have some dipole moment, it is a polar. Got it? Next one. Some of the, we did now diatomic molecules AB type and triatomic molecules AB2 type. Then we'll do for tetraatomic molecules AB3 type molecules. In case of tetraatomic molecules, like AB3 type molecules. AB3 type molecules. Right. So for example, you consider H2O, H2S and SO2 molecule. Right. Here oxygen is the central atom, my dear student. It is approached by two hydrogens. One oxygen, two lone pairs of electrons are present. Right. Here, oxygen is more electronegative. The bond dipoles are moved toward the oxygen atom from hydrogen to oxygen. And here, lone pairs of electrons are there. So the charge on this lone pairs of electrons is more than the oxygen. So that's why the dipole moment is towards the lone pair of electrons, toward this lone pairs of electrons, right? See, both are in same direction. All the four are in the same direction, right? The same direction, right? So this is the resultant dipole moment. We'll get it. There is sum of all. That is, all are in the same direction, right? If all are in the same direction, all dipoles are in the same direction, then the resultant dipole moment, you get it, that is add up of all the things. So you can consider this is a mu1 or a B, C, D like that. Okay. So it is A, it is a B, it is C and it is a D. Now add it all, that is A plus B plus C plus D. That is mu1 plus mu2 plus mu3 plus mu4. All I have to add up. Then you will get the dipole moment value that is not equal to 0. It is some value is there. For water molecule, this is 1.84 divides. This is the dipole moment of H2O molecule, right? Yeah. Then we go for to do H2S molecule. So here central atom is sulfur. So two hydrogens are there, and sulfur have two lone pairs of electrons. Two lone pairs of electrons are there, right? Then, as you know, sulfur is more electronegative, so the bond dipoles is moves toward the sulfur. So the dipole moment is towards the sulfur, both the dipoles. And this is a lone pair, so lone pairs charge is greater than the sulfur, so that's why it moves toward the lone pair of electrons, right? So then the all are added together, right? Here also. That is, the resultant dipole moment is equal to A plus B plus C plus D, right? Then you will get some value. It is also not equal to 0, my dear students. It is some value is there. It is also not equal to 0. That is, some value is there. But exact value, there is some value is there. Right. Next, what about SO2? Here, central atom is sulfur, and bonded atoms are oxygen atoms. And over the sulfur, one lone pair of electrons is present. Right. Sulfur belongs to 16th group element. It have 6 valence electrons. Right. That is, so this is 1, 2, 3, 4, and this is a lone pair. Right. So one lone pair of electrons are present over the sulfur. Right. Central atom sulfur. Now here, compared to sulfur, than sulfur, oxygen is more electronegative. So that's why the dipole, the momentum of electrons, that is more towards the oxygen atom from sulfur to oxygen. So dipoles are developed here. and towards the lower pair it is towards the lower pair of electrons, from sulfur to lower pair of electrons. So this is the resultant dipole moment of A and B are added because both are in the same direction, but this is opposite direction, right? So that's why the resultant dipole is A plus B, and this is minus C. That means these two I have to add up, and that is subtracted with the C. These values you have to subtract with the C. So that's why you will get some less value, that is right. The resultant dipole moment is not equal to 0, but some value is less. It is some less value you will get because the A plus B value is cancelled by, that is a C, so that's why you get some less value. Got it? This is clear, my dear students. Here, these poles, these dipoles are operated in opposite direction. Opposite direction. The dipoles moves in opposite direction, so that's why. But here, all the dipoles are in the same direction. All dipoles are in moving same direction. So that's why they have some dipole moment. Got it? Is it clear, my dear students? Next, other some more molecules. Take it here. Boron trichloride or boron, okay, BCl3 or BF3 like that. And then AlCl3, aluminium trichloride molecule. And then NH3. And then NF3 molecule, NF3. Right, you compare these three. These are all very important, my dear students. These are these previous year questions. These are all appear for KSET and also APMT and JMains. This is very important. This one also. PYQ means previous year questions, my dear student. Okay. Now in case of BCl3, central atom is boron and it is approached by 3 chlorines as bonded atoms. Right? So chlorine is more electronegative, so that's why the dipole moment towards the chlorine atom from boron to chlorine. And the resultant dipole, dipole moment is a vector quantity. So the dipole moment of these two is in this direction. So that is equal to this. It's both of opposite direction. It is cancelled with this one. And the dipole moment of these two in this direction, it is cancelled with this one, right? And the dipole moment of these two this direction, it is cancelled with this one. So that's why. So this is cancelled with this is cancelled with this is cancelled with this. Got it, my dear student? Okay. So that's why the resultant dipole moment is 0. So BCl3 and boron trifluoride BF3 and boron trihydrate BH3. Okay. So we can consider that is BCl3 BF3. This all dipole moment is 0. Alright. So that's why this is a non-polar molecule. Non-polar molecule, right? Non-polar molecule, right? Okay, fine. AlCl3, it is visible, my dear student. Okay, fine. AlCl3. So in case of AlCl3, central atom is aluminium, and it is 3 chlorines are approached. They form 3 covalent bonds around the central atom. And here, as you know, there is chlorine is more electronegative, so that's why the dipole moment is moves toward the chlorine atom. So the 3 dipoles are there. All these dipoles, the resultant is a vectorial combination. So that's why the 2 dipoles, these 2 dipoles are operated in this direction. It is cancelled with this one, and these 2 dipoles are operated in this direction. It is cancelled with this one, and these 2 dipoles is operated in this direction. These 2, okay. This and these 2 operate in this direction, okay. So it is cancelled with this one. So that's why the net resultant dipole moment is is 0. So that's why it is also non-polar molecule, my dear students, right? Then NH3 and NF3. It is so many times it is appeared for different combined examinations. These two NF3 and NH3, ammonia and nitrogen trifluoride. Yeah. So the nitrogen is central atom here, and 3 hydrogens are bonded atoms. They form 3 covalent bonds. And nitrogen is belongs to 15th group elements, have 5 valence electrons, and by using 3 valence electrons, it can form 3 covalent bonds with 3 hydrogen atoms. And 1 lone pair of electrons present about the nitrogen atom, right? So now the dipole moment is hydrogen is less electronegative, nitrogen is more electronegative. Yeah, nitrogen is more electronegative. So that's why the poles, the bond dipoles is moved toward the nitrogen atom. And lower pair of electron is there. So that's why the lower pair of electron charge is more. So that's why it is greater. So that's why then the nitrogen is the dipoles. There is a dipole might move more towards the lower pair of electrons. So that's why. So all are in the same direction, right? So all these are the same direction, Okay. So all dipoles in same direction, operated in same direction. So that's why all are add up together, A plus B plus C plus D. So that is the resultant dipole moment is equal to A plus B plus C plus D. So that is how much that is? This is nearly about, this is 1.4 dividers. 1.4 dividers, my dear students. Okay, 1.46 actually, that is 1.46 dividers. Is it clear? Right, it has some dipole moment, 1.46. But what about NF3, my dear students? Yeah. So in case of NF3, right, in case of NF3, central atom is nitrogen and it can form 3 covalent bonds with 3 F fluorine atoms, and both the nitrogen, one lone pair of electron is present. Yeah. So now what happened here? One lone pair of electron is present. Right. Now, so then compared to nitrogen, F fluorine is more electronegative. So that's why the bond dipole moment is toward the fluorine atom. So that is from nitrogen to fluorine atom. Right. So because of, and its low pair of electron is there. So it is more charged than this. So that then nitrogen it moves toward the fluorine pair of electrons. So then these two, that is these three are in this A plus B plus C are in one direction. But low pair toward the low, that is the dipole moment due to low pair of electrons is in the opposite direction. That's why that is the resultant dipole moment. You will get it. My dear students, the resultant dipole moment you will get it. The resultant dipole moment is you will get it by adding these three. That is A plus B plus C minus D. You have to subtract. This is D. Okay. Right? Then automatically you will get the value. It is lesser. The value is you will get to 0.2 dividers. 0.2 dividers. The resultant dipole moment of NF3 is 0.2 dividers. Is it clear? So that's why if they will ask NH3 and NF3, which one having highest dipole moment is NH3 because it is 1.46. It is NF3 is 0.2 dividers. So it is less than NF3. Why? Because so in case of NF3, so due to high electronegativity of fluorine, the dipole is towards the fluorine atom, and due to low pair it is opposite direction. But in case of NH3, so hydrogen is less electronegative, nitrogen N is more electronegative. So all the dipoles are moves towards the nitrogen and due to low pair also towards the same direction. So that's why all are add up together. But here A plus B plus C in NH3, all A plus B plus C plus D add up together. In NF3, A plus B plus C add up together, that is subtracted to the D. Right? Got it? Is it clear, my dear students? Yeah. So I think I hope you are enjoying my video. All concepts I explained clearly. Okay, you can get it the concept clearly, right? Then like it, subscribe it, and share to your friends. The next video I'm going to share to you. There is part 3, dipole part 3 in the organic molecules. That is also very important. Okay, keep on watching my dear students. Thanks for watching my video.